Let's get to know some theoretical stuff in here, what we need to know before getting into the evading techniques in firewall, IDS and honeypots. So we'll start with the IDS, intrusion detection system. IDS is nothing but a security software or hardware used to inspect the inbound and outbound network traffic, and it looks for suspicious patterns and signatures that may indicate breach in an organization. IDS checks traffics and signatures that match intrusion patterns and signatures, and it gives you an alarm when it is matched. So the patterns and signatures will be already there in the database, and it will get matched once the same signature or patterns are matched with your traffic, with the live traffic. Depends on the traffic monitored, IDS will be placed inside or outside of the firewall. Okay, how IDS detects an intrusion? IDS detects intrusion based on signatures anomaly and protocol anomaly detections. What are these three? So signature recognition is nothing but identifying events that indicates that can abuse system. Anomaly detection is nothing but fixed behavioral characteristics. There may be some fixed behavioral that these guys work in this routine only. If you work in this particular routine, if IDS can get some signatures that is very much different, very much strange to your normal routine, then it will get into anomaly detection. And you have protocol anomaly detection. Models are built to explore anomalies in the way of vendors deploy their TCP/IP implementation. That's how this protocol anomaly detection works. And how general indications can happen when some intrusion is going on. File system intrusion, unfamiliar files and new files, and change in permissions and change of file sizes, and rogue files and missing files can happen in your system. And network system intrusions can happen when repeated probes of available services or connections from unusual locations, or repeatable logins from remote hosts, or sudden influx of log data. That are all intrusions of network. And what are the system intrusions? When you have short logs or incomplete logs or missing of logs or modification to system and configuration files, gaps in accounting, system crashes and reboots, unfamiliar process can happen. It will automatically slow down your system performances. So these things are lead to system intrusions. Okay, and types of intrusion detection systems you have in your network, you must have in your network is network-based intrusion detection system and host-based intrusion detection system. So network-based intrusion detection system listens for patterns of an intrusion like DOS attack, port scan, and attempts to crack, and these things. Host-based intrusion detection system audit for events that occur in a specific host, have to monitor each event due to overhead. Okay, and what type of alerts can IDS makes? True positive, false negative, and true negative. What is this true positive? If some attack happen, then it will create alert, that means true positive. What is false positive? There is no attack is happening, but IDS can create alert, that means false positive. What is false negative? Attack is happening, but still you are not getting any alerts from the IDS, that is called false negative. What is true negative? If attack is not happening there, and there will not be any alarm, that is true negative. Okay, and next we have firewall. Where a firewall can be hardware or software used to protect unauthorized access to and from in a network. They are placed in gateway between the two networks, okay, which is usually private and public networks. And firewall examines all the messages entering or leaving the intranet and block those does not meet the security criteria. And you have hardware and software, both type of firewalls are available, and you have firewall architecture and like bastion host and screen subnet and multi-home firewall also. And you have DMZ, demilitarized zone. So when you have demilitarized zones in your network, that means you are isolating your sensitive critical assets in a separate environment, and you are giving away your publicly accessible server to the public users. That is called demilitarized zone. So no one can access your sensitive critical assets, and they can access only their data which is allowed in web server or mail server, anything like that. Okay, and you have firewall technologies. we have different types of firewall technologies for packet filtering, circuit level gateways, application level firewalls, stateful multi-layer inspection, application proxies, virtual private network, many types of firewalls. When you have filtering firewall, it works at a network layer of OSI model, like TCP/IP, IP layers of the OSI model, and you have each packet is compared to a set of criteria before it is forwarded. Depends on criteria, firewall can drop or forward the packet. Rules can be added to destination IP, source, or destination port, numbers, and the protocol used also. Okay, and you have circuit level gateway firewall. That one works in the session layer of OSI model. Information passed to the remote computer through a circuit level gateway appears to have originated from gateway. So they monitor the request to create sessions. Okay, so circuit proxy firewalls allow and prevent to data streams. Application level firewall works in application layer of OSI. Traffic is prohibited for services that supported proxies. And application level gateways are configured as web proxy prohibits FTP, telnet, and other traffics, gopher. And you have examining of traffic and filter facility in application level firewalls and specific commands such as HTTP post and get methods. Okay, and you have stateful multi-layer protection firewall, multi-layer inspection firewall. So these combine other three walls. These combine other three firewalls like packet filtering, circuit level, and application level firewalls. They filter packets at network layer of OSI model to determine whether the packets are legitimate, and they evaluate at the application layer. And you have application proxy in here. It works as a proxy server and filters connection for specific services. It filters connection based on services and protocols. For example, FTP will only allow FTP traffic to pass through, while other services and protocols will be blocked. The same way application proxy works. And you have virtual private network. Virtual private network is established for virtual peer-to-peer connection through dedicated connection used for secure transmission. Only you can compute device running through VPN software that can access the VPN. And you have firewall limitation, various limitations in firewall. It can't protect from new viruses, backdoor, and insider attacks. It can't protect when network design and configuration is faulty. It's not an alternative to antivirus or anti-malware. It can protect social engineering threats, password misuse, high level of protocol stacks. Attacks originating from common ports and application can also not be restricted by firewall, and it is unable to understand the tunnel traffic also. And you have the next thing we have here is honeypot. Why we need honeypot? Honeypot is nothing but a trap we set to lure attackers, to trick attackers, to deceive attackers, to prevent the unauthorized activity into our network. So any traffic probe or any scanning or any attacking or any compromising activity by an attacker will comes to our knowledge with the help of honeypot. So it can be log port access attempts and monitor key logs. So what we can do, we will be setting up a block hole or a trap hole to trick the victim, to trick the attacker, to deceive that something is there, some vulnerable service is running there. So he will be trying to access that particular service, and we can identify the guy who is attacking in our side and who is probing our network with the honeypot. And we have low interaction, medium interaction, high interaction, production honeypots, and research honeypots. So limited number of services to collect higher level of information will be used in low interaction one. To simulate a real operating system application services, medium interaction one. It simulates all services, complete information about an attack vector, tools, intent. Production honeypots is like emulating real production network of an organization set to collect internal flaws and attackers within the organization. Research honeypots is mainly used by government, military research, and other research units from the government to carry out to exploit the attacking techniques. And we have a tool called SNOT, IDS tool. SNOT in here we will learn that practically what are the things we will look for, what you need to configure in here in IDS, detection operator, IP addresses that you need to use, and what are the IDS evasion techniques we have in here. We will see that now. SNOT we will see practically. And we have in IDS evasion technique, insertion attack, evasion attack, denial of service attack, obfuscating, and false positive generation, and session splicing, Unicode evasion, fragmentation attack, overlapping fragments, time to live attacks, invalid RST packets, urgency flags, polymorphic shellcode, ASCII shellcode, application layer attacks, desynchronization, post-connection sync. Okay, we have this much type of evasion techniques along with encryption and flooding attacks also. So out of these attacks, we will be concentrating very major techniques like obfuscating, fragmentation, and evasion techniques. In insertion attacks, attacker confuse IDS by forcing it to read invalid packets, and IDS blindly accept the packet that an end system rejects. So attacker insert the data into the IDS. So network IDS is less strict in processing the packets than the internal network. So attacker obscures extra traffic and IDS concludes traffic is harmless. So hence IDS gets more packets in the destination. So evasion techniques can be used by attacker to evade IDS by using the attacker exploit the host without the IDS ever realizing it. Attacker sends portions of requests in packets that IDS mistakenly rejects, allowing the removal of parts of the stream from the IDS. And you will carry DOS attacks in the centralized IDS, in the centralized servers for logging alerts. We can take down the whole logs and we can take down the whole servers that can responsible for logging, and we can take down and we can evade the IDS. Obfuscation techniques are we can use in our payloads, in our Trojans to bypass IDS filters, but can be understand the IIS web server. And polymorphic code means to circumvent signature based IDS by creating unique attack patterns. So attack does not have single detectable signature. Okay, and we have false positive generation, crafting malicious packets just to generate alerts, to generate large number of false positive. They will use false positive alerts to hide real traffic. So they will bypass IDS as it is difficult to differentiate the alert traffic and the false positive. And we have session splicing attack, Unicode evasion technique in the URL itself, and we have fragmentation technique, and we have overlapping techniques, and we will learn about time to live attacks, and we have invalid RST packets and lots of techniques in here to bypass IDS. When you go with firewall evasion techniques, you have IP spoofing address, IP address spoofing, source routing, HTTP tunneling, and bypassing firewall through SSH tunneling, and through external system, through man-in-the-middle attacks, and through HTTP attacks, and bypassing WAF using XSS attacks by giving these kind of obfuscation scripts. Okay, and we will learn these bypassing techniques practically, and you will get to know how you can bypass firewalls using different scripts in Nmap, and what are the techniques you can handle, and what are the scripts you can handle in XSS to bypass web application firewalls and other techniques also. And you have detection of firewalls and detection of honeypots and detection of setting up of honeypots in here. So we can set up honeypot in here using a tool called Pentbox. We will see that now, and then we'll go for the practical session. Let's dive into the practical stuff now. Okay. And
okay, they have some GUI honeypots. I don't prefer that. I always Pentbox if you want a honeypot. Okay, so what is honeypot? First of all, what is honeypot? Yeah, Pentbox. Okay, so Pentbox is a tool. You have multiple features in Pentbox. Okay? You can git clone it from GitHub. Simple git clone. You can use it from GitHub. Okay, so that's what you can use it in GitHub. So this what is honeypot actually? No, honeypot. If you put honeypot in the open place, what will happen? Bees, flies, lot of things will come around that honeypot, right? For what? The honey. Okay. So what is happening with the honeypot in here? We'll be setting an honeypot with a fake fake service running on it. So when attackers scan your network, when attackers scan your system, you'll get to know there is some vulnerable services running, but you don't know that it is a honeypot. Okay, so he will keep on attacking on it. Okay, but there is no such thing. It is like black hole. So there will be no such things, and he will try attacking on that, and he will not gain any access. He will not gain anything from there because there is no such thing. So for example, you can put FTP is open. We know FTP is very vulnerable, easy to crack. So he will try on with FTP brute forcing technique, all techniques, we will try one by one, but nothing will work. Okay, so we can just divert the attackers to the honeypots and keep our very own services and servers very safely in the other ports and other services. Okay, for that we will be using honeypots. So how we can create honeypot? With the help of pentbox, we have that. So we can be able to know who's attacking, attacker details also. Okay, with pentbox. Okay, here and pentbox.rb. Okay, Ruby file, right? See, we have this much: network tools, cryptography tools, web IP grabber, geolocation IP, mass attack, license and everything. Okay, in here. So let's go for network tools. You have NetDOS tester, TCP port scanner, honeypot, fuzzer, DNS and host gathering. We have lots of tools here. Let's go for honeypot. Okay, we have honeypot, and you must run the pentbox with root privileges. Yeah, I'm a root, and here no issues. Am I root or not? Yeah, I'm root. Okay, so what kind of configuration you want? Manual configuration or fast startup configuration? So I'll just go with fast startup configuration. How we can easily set up on. See, honeypot is activated on port 80. Simple. Okay, so you don't need to do anything. You don't. If anyone attack on port 80, it will trigger an alert here, and you can go on with it. If it is port 2, like if it is manual setting up, let's check for manual one. Network tool, honeypot, and manual configuration. See, insert port 2 open. I'll put like 21. Okay, so 21 is FTP or 22 is FTP? 21, right? Yeah. So, insert false message to show. I'll put FTP. Any vulnerable FTP server, like go for Google and search for any vulnerable FTP server. Can't get the exploit name, so no issue. We can give any, say, we can give you any VSFTPD like that. Like that. Okay, version number 1.0. Like this. I don't know, like I'm just giving false message. Enter. So save a log with intrusion. Yes, we need to save logs. Okay, it will be saved in this log.honeypot.txt. Whoever just scan the system or whoever tries to access our system, it will get stored there. Okay, and I'm going to like default any like what kind of file you want to save. If you want anything, you can give. Otherwise, you can just give enter. Yeah. Do you want the beep sound when intrusion happen? If someone scanned your system, it will give the beep sound. Yes. Okay. Honeypot is activated on port 21. If someone scanned your system, you'll get. Let's see. It's not possible to scan our system from very own system. Clear? config nmap -t4 -a 192.168.1.104. Let's check that port 21 is really open and it is showing something or not. Beep sound came, right? Go for pen box. Intrusion attempt detected. Someone is scanning at port 21. Can you see this? From IP address also. From the port 531.53518.
This is very good.
Version binding, HTTP, RTSP. So these kind of things happening when we start scanning with nmap. Okay, this is what like honeypot we do. If someone scan, we can easily find them who is attacking from the IP at what time, what is doing, everything. So he's using nmap. Okay. So network program, networks. So every information you're getting, see one by one, what nmap is doing in the background, it will give you the details of one by one. Okay. So let me stop it here. Let me try this one. FTP 192.168.1. This is how you communicate with FTP. Connected. No, I think I gave the wrong command. So no issues. Started detecting, but not the very well. Okay, so this is how you can play with honeypot and all. So why I showed in here, like this tool is good. With Ventibox have multiple options, not only honeypot, geolocation IP, IP grabber, network tools, lot of tools we have. You can use it in Ventbox, but this tool, this one, lab is not having much. They give honeypot. When honeypot is there, I don't like this one. I don't like it.
No, but if they are using, if the attacker is using some another port like 21 or whatever, like 25 or 27, then we won't be able to detect now this honeypot.
No. See why we are deploying this honeypot, especially to divert him. Okay, so to divert him. So we just set it up some honeypot details in port 21. Why we are setting in port 21? FTP is very vulnerable. People know that FTP is vulnerable, right? It is not having strong authentication mechanism. It is not encrypted data and all. Okay. So if attacker comes in with scanning, after he done scanning, he will first see, will be like, oh my God, FTP is there. So I have to attack that. Okay. He will try attacking on that, but he will not gain anything. Okay. That's why we are putting that one. If we are having SSH, why you need to create honeypot on SSH? SSH is secure. You don't need to create on that one. You have to divert him through some vulnerable one. Okay, that's why we need to go for any vulnerable. You can open any port, maybe port number 5,000, 50,000, and we will ask him to like any service. What kind of service he will easily target? That kind of service. SMB. Okay, take SMB, put 135, and put the SMB service open, and you can enable that version also, MS17010, Eternal Boost series. Okay. You will scan and you'll come to know, okay, oh my God, Eternal Boost there. You will try on. Nothing will happen. You will not get shell because my Windows is not vulnerable to Eternal Blue. He will try, but nothing he can gain. That's why you implement honeypot to divert him. Okay, when he's doing that, he will scan and all. We will get alert. So we'll come to know some intruder is there or someone is trying to attack. Trace him, what he's doing, why he's doing everything. Okay. So in the meantime, like he will be attacking and he will facing the failures, we can catch him. Okay, so that's the thing with honeypot. And next thing we're going to do is how to bypass firewalls and IDS and some informations with how to bypass firewalls and all. So this is using Metasploit. My God, it's very bad. Yeah, honeypot I've shown you. Okay, what software IDS is there? Okay, okay, let me teach you firewall first, and then we'll move towards IDS. Okay. Like I don't want my terminal to be like messy one. That's why I'm CD and clearing everything. Okay. Here, what we have, Nmap. Nmap will do all the things. Okay. My Kali machine is like my Windows machine is it's not displaying any ports open. Okay. Let me try with a normal scan first, and we'll try bypassing our firewall. -T4 -A 192.168.1.8. This is my host Windows IP. Maybe we'll check it. .8. Okay. So let's try. What we get here, we don't know any open ports is open or not. We can see that all 1000 ports are sitting behind a firewall and we can't find anything. Okay, so we're going to use multiple firewall bypassing techniques. Okay, I think 4 or 5 I'm going to teach you on CH.
First thing here is stealth scan you can use. Sometimes this will give you an advantage when we go for stealth scan. Stealth scan also help with bypass firewalling sometimes. Okay, let's try. We'll try to get something or not. Okay, it didn't work. No problem. Let's go for some other technique. Okay, we'll go for -PN. Okay, so this is a very old one, but we'll try it is working or not for bypassing firewall. And next method we are going to use is fragmentation technique. Let's see this one is working or not. So these are all the script, like these are the arguments used to bypass firewalls. Okay, so in what way we can try, like we have 3 more commands for you. We will use zombie technique, we'll use decoy technique to bypass firewalls and IDS. The same thing, same technique you will use in IDS also. Okay, so IDS is not like much thing with IDS. From ECSA, I'm going to teach you one more thing from IDS, how attackers encrypt how attackers bypass IDS. I'm going to show that part. We'll see. Okay, yeah, few more tools with IDS. We'll see IDS and firewall. Okay, we didn't get anything in here also. No issues. Go for fragmentation technique. Okay, so when we are going with this type of scanning and all, I always don't prefer go for T4 or like aggressive scan. So always go for soundless scan. So it will also help you sometimes. So T0 is very slow scan, but it will give you a favorable result that you are expecting. If you go for sound scan, your IP will get registered, like your IP will get stored in your victim's machine, victim's defensive mechanisms like IDS. There will be UTM, universal threat management. Let's check. Why it is taking this my okay sound like T0 now, that's one. Actually, it will scan for the operating system. It scans for operating system details also, but it cannot find the specific operating system details. Okay, so like fingerprints means like you can say signatures. Okay, so when it's trying to find out the operating system, but it can't find the specific one, you can say sometimes the Nmap will not give you the perfect operating system information. Okay, so let me search this Windows 7's operating system. Let's see, 1.4, right? Let me run nmap scan here. Nmap hyphen T4 A hyphen O 192.168.1.4. Okay, let's see what operating system it is giving. So it will not give you the full operating. This is Windows 7. It will not give you. It will give like a probability, like it can be Windows Service, Windows XP, or 7 or 8. So this kind of probability it will give you.
Okay.
So it tried with many fingerprint. Okay,
but everything looks like the same. It cannot give the specific OS details in here.
Okay. Okay. Then give us nearest one.
Yeah. See, Windows 7 Professional or Windows 8. It can be Windows 8 or 8.1 or also. It can be Windows Vista also. Okay, but mostly we have a lot of Windows 7 operating system details. So we can come to a conclusion that there may be a chance of Windows 7. Okay, so Windows 7, 8.1 or Windows Vista or Windows 2008 server. There may be chances of all these four. Okay, so this is how you can come to one solution with operating system details. What happened with this one? God, T0 is taking too much time. Yeah, T5, the insane scan. You can say very fast one. Or you can go with like depends on your scenario. T3 many people use T3 also. But if you want like a stealth or silent scan, T0, T1, T2.
Okay.
Okay, it is taking too much time. Okay, let it scan in the background. Let me proceed with the other type of scans here. Okay, so we have a technique in Nmap called decoy. Okay, so what is this decoy? Who's our target here? This host is our target. So what we're going to do, we are going to set up multiple IPs, decoys, to make full of that Windows 10. By how? So it will send multiple requests from all these decoys. So for example, I can choose random 10 system like this. So it will take 10 IPs and it will send requests from 10 IPs, random 10 IPs. Okay, and it will send random 10 IP requests to all these to the particular machine of my Windows, like this machine. So what will happen? My Windows machine can't identify who is the legitimate user, who is legitimate request, where am I receiving all this, from where am I receiving all these requests. It will get confused and it will allow everyone, and you'll get the open ports and details. Okay, let's see. Okay, so that's what -d means, decoy, and random 10 decoys you can choose, or you can go with this also, this type also, nmap -d. You can use not random. You don't want random IP addresses. You can go like 192.168.1.1. Sorry, 2, or you can give 92.168.1.3 like this. You can give, I think, comma will come. You can give like this, and your target 192.168.1.8 like this. So what will happen? It will use these two machines as decoy machines, and it will attack on this machine to enumerate the port details and services details from this Windows machine. So let's see, we have, okay, this technique also didn't work in here, no problem. Another technique we have is SI. Okay, what is this SI means? Idle scan. Okay, zombie scan. You can use any 192.168.1.4 I'm using. Okay, so what is this scan? -S means, small s means scan, and capital I means type of scan we are carrying. I means idle scan, also known as zombie scan. Okay, so what is this zombie scan is doing? It will use this device as zombie. Okay, multiple requests will go, not multiple requests. This will also give requests. This will also give the request. The Kali machine also will give request, but it doesn't know which one is really accepting, like really giving my request. Okay, it's exactly somewhat related like decoy, but the Windows machine will not have any idea who is giving the request. Okay, let's see. See, many people use -B small n, but that doesn't give us good results, right? So that's why we are using idle scan here to bypass firewall. Okay, it didn't also give that much. Okay, so that means my device is much firewall is very much secure. Okay, that's good. Okay, you have multiple firewall techniques also, how you can scan firewalls with the data length package, MAC spoofing methods, IP spoofing methods also. So everything you'll see, like you'll learn it in ECSA too, how you can pen test firewall with this kind of techniques one by one when you go with ECSA. Okay, so in here, God, it is still running. Okay, so these things you can go here, and any other command I need to show in bypassing firewalls. Okay, I'll show you one more command. If it's not in the servers, okay. --MTU. Okay. So what is this MTU means? Maximum transmission units. So every packet will be carrying some transmission units with it. Okay. So you can set this maximum transmission unit in the multiple digits of 8. Okay, you can 8, you can add 16. Okay, like this. So this maximum transmission unit determines how much packet should be sent in, like in fragments. Okay. So when we are carrying out this -MTU, it will help you sometimes to bypass the firewalls. Okay, let us check. It is giving some good result, favorable results or not. If you take like Google it, like how to bypass firewall using Nmap, you have scripts also in Nmap to bypass firewall. Too much of script, too much of commands to bypass firewalls. Lots and lots of techniques. Okay, as a network administrator, if you want to harden your firewall, you need to like check for where, like you have to limit your request. Okay, like we have said now, we have to like limit that port numbers in switch security. Exactly like you have to go with this also. So you have to maintain properly with proper firmwares and updates, and you have to configure the firewall rule set, which one should be allowed. If someone is giving ping request from multiple ping requests from one IP, you have to drop that request there itself. Okay, so they have to deploy multiple rule sets to avoid firewall bypassing. Okay, that all comes under firewall hardening and firewall configuration techniques. Okay, so honeypot over, firewall over. Next, we are going to move towards IDS. Okay, what is IDS? Intrusion detection system. Okay, intrusion detection system. Okay, so what we have in intrusion detection system, we have one software, free IDS. You can use it in your system, like Snot. Okay, you can install it and you can use Snot. But I'm going to show you how hackers do this, how hackers bypass IDS. Okay, simple. Okay, by encrypting their payloads and all. So I will be using one more system here to show you. Attackers will do this like encryption standards, how attackers first of all, before continuing with this blah 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 stuff, let me tell you how IDS works and what is happening with IDS. Okay, so IDS works with signatures and patterns and packet data and all. So IDS, what we'll do, if there is some traffic going on, there is some communication going on, if there is some network related stuff between two nodes, that means one system to another system. Okay, so what happens, this IDS will detect any malicious activity, depends on the signatures, patterns, packets, data. Okay, so IDS detects. Okay, if there is some normal which is going on between two systems, it can easily detect. Okay, so for that I'm going to show you one technique here. So how two systems are connecting between reverse connection. Normally, when you're getting this the system hacking stuff I showed you now with MSF Venom, with MSF console, if that kind of reverse connection is going on, this connection is not an encrypted one. Okay, so it can be in IDS. Okay, to avoid that, what hackers do? What hackers do? Let's see first that. Okay, so ncat LVNP. I'm just creating a reverse connection with my Linux and Ubuntu machine here. Okay, so I'm just giving away my bash shell. So netcat and ncat, like both are same kind of thing. Ncat is a part of nmap, and netcat is nc. So that's the difference. Okay, so I'm just opening a shell -e execute. I'm giving away my shell through this port. Okay, I'm going to access the same thing from here. Terminal in Ubuntu machine. System is hanging. Let me stop it. 16 GB. What happened? Okay. So what I'm going to do here, I'm going to do the same ncat, okay, and I'm going to listen to the connection V and IP of the Kali machine 192, because I'm getting that shell, right? 192.168.1 dot what? 104, okay. 104, okay, and I'm going to give the port number 1234. That's what I'm listening, right? Enter. See, I'm connected here. Okay. Before I want to show something, open Wireshark in here, so that I can clearly show how hackers communicate between two machines, what is happening in here, and IDS will, how IDS can easily detect it. It's still going on. Let me stop it. God. So Ethernet be my interface, right? So, okay, it is going on. Now I'm going to Ubuntu. I'm going to perform some commands. ls. I'm going to get any folder here with sublister. ls. So these kind of commands he will be doing. The attacker is connected with some machine and he's doing the reverse connection and he's working on it. Okay, but how IDS can find it? Because reverse connection is not an encrypted one. Okay, reverse connection is not an encrypted one. So he might have seen some IP address like this, like TCP connection. Wait, let me stop it. So it is going on like, okay. Okay, so any TCP communication, if you follow some TCP connection, communication protocol, like system is very slow. Okay, follow TCP free. See the commands you performed and the result it displayed. Everything you can see, CD, sublister, ls, everything you can see. So with these kind of things, CD, ls, nano, and these kind of commands can perform. If it is going in the IDS traffic, it can easily capture. It can easily find out that someone is inside and they are communicating, that the reverse connection is going on. So what will happen? IDS will just detect it and IPS will cut it out. Intrusion prevention system. Okay, it will cut that communication there itself. Okay, but what hackers will do to avoid this kind of techniques? So hackers will go for encryption techniques. Okay, just simply they will like use encryption standard, different encryption standard, by adding SSL with it. Okay, they will use encryption standards, and you can see the difference between the normal shell and the encryption standard shell. Okay, now everything is connected again, and let me start Wireshark again, so that we can see the difference of both. start, continue without saving. Ubuntu, I'm going to give the same ls command, cd, seeker, ls. So these kind of commands you can perform, and now go back to Linux machine, check for the TCP stream, right click it, follow TCP stream now. See, encrypted one. Okay, so these kind of encrypted communication cannot be detected by IDS if you are not configuring the IDS properly. Okay, so we have to check for the encryption standard is properly implemented, the encrypted standard level of detection. Okay, we have to ensure that our IDS is properly configured with proper encryption standards. It have the ability to detect that encryption standard is also there or not. Okay, so we have to check for that also in IDS. Okay, so next thing we can see in IDS, any important stuff. Yeah, one more evasion techniques in Nmap. How you can use Nmap technique to evade an IDS one. Okay, sorry for that. I can't show you the IDS technique because we don't have IDS, right? So I'm just giving command --, data length. Okay, why data length? Data length matters the most when the IDS configuration is working. So IDS works with this data length also. So we can use any data length to modify our scanning thing, our scanning part. So we can use this kind of data length, and you can give the IP to scan to bypass that IDS and all. Okay, with this that ideal scan, random decoy, all these commands will also work with IDS also. Okay, the bypassing of firewall techniques also works with IDS also. Yeah, so things you can perform in IDS. And only one more thing left today is I have to show you the snort IDS, how you can work with snort IDS. Okay, so how you can install and how you can install like snort IDS here. So like it's very big one.
And we learn here how to set up snort and what we're going to do with snort, everything step by step, one by one. Okay, I have a machine here, Windows Server 2012. I'm setting up snort in this one. I think snort is already installed in this. Let me check. Yeah, snort is already installed, but no issues. Let's go back to the snort machine in here. And you have snort rules. So IDS works with set of rules and functionalities and patterns, right? So we have a set of rules in different folders. So these rule sets are very mandatory for the functionality of snort. So what we're going to do, we are going to copy these snort rules and we are going to put it into the installation folder. So I'm going to copy this snort.config file. This file is responsible for your snort functionality. Okay, so let me open a new Windows. Sorry for that. And I'm going to put that file in here in etc folder, the config file. So whenever you run the snort, this is the file that comes first, and it will call all the set of rules again, and it will ask me to replace, and you have to replace it. And now we have the other set of rules that we need to replace in this installation folder. Okay, so I'll just go back and I need to copy 3 directories in here: pre-processing rules and SO rules. So I'm going to copy all these 3 directories and I'm going to put that in the installation folder. So I'll copy the whole 3 folders and I'll put this in here. So I'll be fast forwarding this. Okay, it is copied now, and now I'm going to check that snort is working perfectly or not. So what I'm going to do here, in the bin folder, you have to open a command prompt in this bin directory. So I'm holding down my shift key and I'm opening command window here. Okay, so in here I'll just try to type snort and I just press enter, and it is starting, and initialization is complete, and now we comes to know that snot is working perfectly. Okay, now what we're going to do here, after you have to do press Ctrl C to exit this snot C, and you have to type snot hyphen capital W, the uppercase W, for what? To choose your physical interface, how many interface you have and what physical interface you will be using for IDS monitoring purpose. So I will be using the physical address in here. I'll be using the first one, so I need to use the first one. So I'm using snot hyphen the device ID, device interface hyphen I1. Here I'm using first one, so I'm using 1. Okay, so everything is ready, so it will go as usual. Okay, now whatever you do, if you start to pinging everything, you can see it will be. Let me open a command prompt, and you can see that if I do pinging from another system, if I do pinging from my system also, it will give you the alert that someone is pinging your system. Okay, but we need to configure the set of rules and configuration. We need to set up rules in configuration files that we will do in a minute. Let me try to ping it. Okay, ping 10.10.10.12. This is the machine in IP address, and I'm going to ping that machine. Sorry, I'm going to ping the 10.10.10.10. So the external machine in here, and it is pinging now, and you can see that what happening to here in here. So you can see that pinging is happening between two machines, and you will get alert in snot. Okay, so what I'm going to do, I'm going to close both the snot machines in here, and I will be working with now the rule sets. Okay, clear screen, CLS, and now I'll open snot etc directory. Okay, so in snot in etc directory, get into the etc directory, and you have snot.config file. So open this file with notepad++. Why? You can open with normal notepad also, but you need to work with different line numbers. Okay, these line numbers will be very helpful for you to set up the rules. Okay, that's why. So you can find the line numbers in notepad++, not in normal notepad. That's why I'm using notepad++ in here, and I'm going to the line number 45. So this line number 45 holds what IP addresses that you are protecting. Okay, in here if you have external IP addresses, DNS server, SMTP server, HTTP, SQL server, different servers. If you have it in your hands, you can give that IP addresses in here. So for now, for demo purpose and for education purpose, I have only one server, not even server. Yeah, you can say server. I have my machine 10.10.12. That is my installed machine. Okay, so I saved in here and I left all the things behind, and I'm going to the line number 104. In here in 104, you need to give the path of the rule sets that you have copied. Okay, the rule path, SO rules path and pre-processing rules path. So in 104, 105, 106, you need to specify the exact path. So I'm just giving C:/snot/rules. So the same thing in here. C:/snot/SO rules, and in here the same thing. C:/snot/SO pre-processing rules is already there, so I'll just have to save this file. I press Ctrl S and I saved it, because you usually do that to save all the things. So in line 109 and 110, you need to add two more path, C:\snot. /rules. So same thing in here, C:\snot/rules. Okay, so everything is set. Now we navigate to snot rules folder. Okay, so we need to work and we need to create two files in there, and we will go to the snot rules folder. For some reason my lab is very slow today, but don't worry, it will be good enough to work with. I hope it will not show any error, any difficulties when we scan the real-time one. So I will be going into this rules folder, and you will see lots and lots of rules that how IDS works. Backdoor rules, browser rules, chat rules, DNS rules, DOS rules, FTP rules, ICMP rules. These are different rules and patterns and signatures that IDS needs to work with. Okay, so if some patterns are some signatures match with these rules, definitely it will give an alert. So that's how IDS works. So what I'm going to do here, I'm going to create two files in here. Okay, so I'm going to create new two text files. Two new text files. I'm going to name it as white_list.rules. The extension should be in the set of rules. Okay, enter. It's okay, I want to change it, and I want to give right click, new text document, and in here I'm going to give black_list. instead of .text I want to change it to .rules. Okay, so enter, and rename it will say that it may be unstable, so no problem. And in here the next thing we are going to do, and get back to your config file in here, and you have to move to the line number 238, the rule set for your dynamic link library files. Okay, so in dynamic loaded library files, and you need to keep the exact path that you want to configure for dynamic load link library files. So in line 243 you need to replace this path to something else that I'm going to give in here, C:\snot/lib/snort_dynamic preprocessor. Okay, so we have given now, and at the path to base processor in here, where is the base processor in here? Dynamic processor, dynamic engine, dynamic detection. Okay, at line number 246, that's here you're going to change it to replace this whole line engine.so to engine.dll file. Okay, that's what we're going to do here. C:\snot// and snot again _dynamic engine preprocessor. Okay, and actually not preprocessor, dynamic engine. Okay, go back, dynamic engine /sf_engine.dll file. Okay, and we are going to comment out the line number 249. We don't need this 249 line anymore. You need to comment it out, and you have to move it to the next line 252 for configuring process. Okay, in here you need to comment out, because these mostly creates lots and lots of false positive and errors at the running time. So you need to comment out from 261 to 265. Okay, so I'm just commenting out by adding hash in the front, hash 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 hash. Okay, I added now. Now what you're going to do, we are going to move to the next line 325. Okay, this line you need to delete this LZMA in here. Okay, so you need to delete this one. Delete this and save it. Don't forget to save it often, because anything can happen, power cut can happen, your system may crash, and you need to do it once again from the very first. So we don't want to afford that much of time effort, because time matters the most. Okay, so in line number 5049, okay, you need to go to line number 504 in here for the next setting up of things in here, and in here 504 to 509 you need to add backslash at the back. So okay, sorry, for that you need to remove it. If there was already the backslash, and you need to remove it, the backslash, remove all the backslash, and you need to comment out these lines 504 to 509. Okay, we don't need this anymore, so comment it out. Okay, so I commented it out, and you need to go to line number 512. So this is the section for configuration of output plugins. Okay, so you need to give the plugins configuration files exactly in here. Okay, so these files are located in etc folder, and you need to change the location in here in 531 and 532. Okay, how you have to change it, you need to give the path, exact path in here. How? You need to include the classification path in here. Okay, so the path will be /etc classification.config file. Okay, so let me type it in here, // snot and /etc, sorry, etc / and classification.config file. Okay, the same thing in here, you need to give // snot /etc / and reference.config file. Okay, and it is done now, and you need to get into output alert system. Okay, so where in here you have to go with, in here you have to go with the step number 6, add at the line 533, you need to add output space alert underscore fast space alerts.ids. Okay, so you just have to give to this, and for snot to dump all the logs files into this folder. That's why you need to add this line here. Okay, so just you have done everything, and you need to find IP var string, and you have to change it as IP. So you have to remove IP and you need to change it to var. So how you can do, by pressing Ctrl H, it will give you the replace function, and you have, in here you need to give find IP var and replace it with only var. Okay, so replace it, all 11 occurrences were replaced in here. All done. Just now close it, and you need to get into, okay, all done. You need to add a file, actually add a rule in ICMP rule set. Okay, so how you can do this, you just have to move into a directory, snot rules directory. Okay, so okay, in this folder, snart rules folder, you will find ICMP rules. So I just scroll fast. Yeah, ICMP info.rules. Okay, this is the one. So let me open it with Notepad again, and I'm going to add a set of line in here. Okay, at the line 21, I need to add a new line. So enter. I'm going to add a line in here, that is alert ICMP, the whole line that contains the information about okay. So actually I can't paste like that, I need to type it, alert ICMP and $. So no need to worry, I can type it, and you need to type it, otherwise no way. We can go in here, home_.net. so if some intrusion happened with this IP address, and it have to give me an ICMP information ping that where it is happening. So that's what we're doing here. So how we can go, I have to create a message, and I need to give an echo like ICMP, sorry for that, my bad, ICMP comma info and ping. Okay, or you can give like this, I think so. No, info ping close it and semicolon, and you have to give icode in lowercase letters, icode :0 semicolon, and I type :8 semicolon and space reference and arachnids, 135 : okay, sorry, semicolon and reference, and you have to add reference CVE, 1999 : 0265 and class type bad unknown. Okay, so semicolon SID. I hope I didn't make any mistakes in here. Definitely if I made any mistakes, it will not give me the expected results, so I don't want that. Let's see what we have given in here. I just added the whole line, a very big line, so it will give me the pinging details if some pinging action happen into my machine. Okay, so everything is done. Now once again I will start my command prompt in the snart bin directory. Okay, you have to start in here in bin directory. Okay, in here you need to type snart -i, and in the place of X you need to give your interface number and -a console -c, and you have to give snart what configuration file it's need to bring when the monitoring happens, etc. snart.config. Okay, and -i c : /snart and log file information. I need to give k. Okay, so k, the output format I want to be in ASCII. Okay, and you can give enter. Now let's check our IDS is running properly in here without showing any results. I'm very fortunate. Yeah, I'm very fortunate, I think so. It is running properly. Now let me move to another machine and start pinging this machine, and we'll wait for the result. how this IDS works on monitoring purpose and all. I'm just going to ping it, ping 10.10.10.12. Just enter. Let's get back to the machine in here. It's not one, and let's check we are getting the probe. ICMP probe is showing some results in here or not. And it gave me an error, something wrong with my command that I've given, and it is showing the fatal error. No issues, I've missed something maybe, but now you come to know how to configure IDS and how to set up the files and rules and all. So we have to carry out one by one, each step by step carefully, then you will be very much clear with the SNOT one. So it's a very basic IDS setup, the software IDS, and you can find lots of hardware IDS and many types of unified threat management machines also available in a day-to-day market. Okay, so that's how you can manage your organization with perimeter devices using IDS, firewalls and honeypots, and that's it for here. Here becomes how to defend against IDS evasion, firewall evasion techniques and all. So to avoid IDS evasion techniques, shut down switch ports associated with known attack hosts. Regularly update and patch all the systems. Deploy IDS after thorough analysis of network topology and nature of network. Use TCP FIN or RST packet to terminate malicious TCP sessions. Update antivirus signatures. Store the attack information for future analysis. Ensure IDS normalize fragmented packets and allow packets to reassemble in proper order. Harden the security of all the devices such as modems, routers and switches. How to define firewall evasion? Configure the filter out IP of an intruder. Rule set to deny all the traffic except the services that you need, and disable the FTP protocol. Catalog and review all inbound and outbound traffic. Control physical access to the firewall. Schedule regular firewall security audits. Specify the source and destination IP as well as the ports too. Monitoring of users access to the firewall and control is mandatory. And you need to carry out the firewall penetration testing process, with starts from footprinting of target. It suits for all the firewall penetration testing, IDS and other devices too. So you need to footprint the target and perform port scanning on it, and you need to check the firewall is detected or not, and perform banner grabbing. Firewall is detected, then you can go for firewalking, and you have to go for no firewall is there or not, and you have to go for disable a trusted host and perform IP address spoofing and fragmentation technique, ICMP tunneling technique, ACK tunneling technique, HTTP tunneling technique, SSH tunneling technique, MITM attacks, SSS attacks to bypass replication firewalls, and at last you need to do the documentation of findings. And you have IDS penetration testing methods to disable a trusted host, and you have performed insertion attack, various attacks like obfuscation, false positive generation, session splicing, unique diversion technique, fragmentation attack, overlapping of fragment technique, time to live, invalid RST packets, and polymorphic shellcode technique, ASCII technique, an application layer, and encryption and flooding techniques. Then you have pre-connection sync attacks and post-connection sync attacks, and you have to document all the findings that you have done. So this is how you have to carry out penetration testing on IDS, firewalls and honeypots. Okay, so we'll see you again in another module. Stick with us, learn with us. Thank you.